Alright, so we're moving on to part B. Alright, now since sine comes first, we need to make sure that it's between negative pi over 2 and pi over 2 because that's the domain. Okay, so since sine is being, we're taking a look at it first, we have to figure out where 7 pi over 6 is, right? So 7 pi over 6, if you know the unit circle, you know that pi is right here. So that's could be written as 6 pi over 6, right? It's the denominator of 6. And so that means 7 pi over 6 is over here, okay? But we need it to be in the first or the fourth quadrant. And then this, if it's in the fourth quadrant, you need it to be written in terms of a negative, right? So what we're going to do is we're going to think about this. Remember that the unit circle follows a pattern, right? So if we have 7 pi over 6 over here, then we're going to have 7 pi over 6 over here, right? And the good thing is that they have the same sign value, right? Because sine in the third and fourth quadrant is both negative, right? So this is good. So instead of using 7 pi over 6, we're going to use this value in the fourth quadrant, which is 11 pi over 6. But we can't write that because that is past pi over 2. And so instead we're going to write it as negative pi over 6. Why? Remember that we can always find a coterminal angle. So in this case, if I subtract 2 pi from the 11 pi over 6 that I want to use, remember that you need to have common denominators. You get the negative pi over 6, and now it is in the domain that we need. Okay, so that means that we're going to be able to do arcsine of negative pi over 6, and then the cool thing is that these cancel now because now I am in the right coordinates that restrictions that I need to be, and so now the answer is negative pi over 6. Okay. Alrighty. Now we're going to move on to compose different functions. So we're going to have a mixture of the regular trig functions and some of the arc functions. Okay, but when in doubt, you can always go back to the unit circle, always go back and draw your right triangle, use SOHCAHTOA. Okay, so we have cosine of arctangent of negative 8 over 15. Okay, we want to find the exact value. Okay, so we have to think about this. So first of all, without plugging into the calculator, we know that negative 8 over 15, of course that's a negative number, and so we're getting the arctangent of this number. It's going to give us something in the fourth quadrant. We've seen that before. Remember that arctangent is from pi over 2 to negative pi over 2, right? So if we're getting a negative, that means that it has returned an angle in the fourth quadrant. Okay, so we're going to draw our triangle there. And we're going to go ahead and we're going to label this according to what's given to us. Okay, so, dun, dun, dun. All right, so we're going to use this. So first of all, we know that we're going to go ahead and we're going to, I was trying to see the best way to explain. Okay, so basically we're going to let this equal an angle, right? Because it does give you an angle when you plug into the calculator. Okay, but we're not doing it that way. We're finding the exact angle by drawing a right triangle. Okay, so if you wanted to solve for theta, what can we do? We can get the tangent of both sides. As long as, okay, I'll show you. Okay, and then these will cancel as long as our tangent, which is the one inside, it says x for all real numbers. Okay, so again, this is all in your textbook, but let's say that we want to compose tangent and arctangent. Okay, So the tangent and arctangent will cancel, and you'll be left with just this x for all x of the real numbers, okay? Whereas if you did it the other way around, then we know that it's going to have to be between negative pi over 2 and pi over 2 as the domain of regular tangent x. And again, we have graphed these, so we have seen that. Okay, so because of all of this, these actually cancel. And so then that basically all of this is for us to be able to label the right triangle. Now you don't necessarily have to, at least when you have arctangent in here, you don't necessarily have to get the tangent of both sides, prove it, cross it. We're just gonna go ahead and say, okay, well for tangent, we know that tangent is opposite over adjacent. So let's go ahead and label our triangle. So this is opposite, this is adjacent, this is hypotenuse. Okay, so based on this, we have opposite, adjacent, and remember that the negative is there, but the negative has to make sense, right? So where would it make sense for the negative to be in the fourth quadrant? Well, not for the 15 because this is cosine and cosine is positive, right? X is positive in the fourth quadrant, but y is negative, so it makes sense for this 8 to be the one that's negative, okay? And so now we need to find the hypotenuse. How do we do that? Pythagorean theorem, right? So we're gonna do negative 8 squared, which is one of the legs, plus the other leg squared equals the hypotenuse squared. Or you can call it r, the radius of the circle. Okay, so basically what we're doing is this is section 5.3, which is also on YouTube. We are using this point 15 comma negative 8 in order to do the trig functions. Okay, so now let's do the math. So this is 64 plus 15 times 15, that's 225, correct? Okay, now we're gonna add them, 289, and then opposite of squaring, square rooting. So you have the square root of 289, which is a perfect square of 17. Okay, so we get 17 here. And now that we have all the parts that we need, we can actually go ahead and solve this out. Okay, so remember that we just labeled this angle theta. Okay, we're letting theta equal what is inside here, right? What we're plugging into cosine. Okay, so we purposely drew the right triangle, we worked it out, and so now we get to just replace the arctangent of negative 8 over 15 with theta because we went ahead and we labeled it on the right triangle. Okay, so we know that where theta is at, we know the information needed. So now we're just going to get the cosine of this theta, which we know that SOHCAHTOA cosine is adjacent over hypotenuse. So adjacent is 15 and hypotenuse is 17. So the answer is 15 over 17. Does it make sense for cosine to be positive in the fourth quadrant? Yes. Okay, so that is our answer. Okay, we're going to go ahead and do another one. Oops, that also is very convenient to always go back to the right triangle. You're going to do this in calculus as well. When you do integration, it's actually pretty fun to do. Okay, so let's check out one more, and then it's going to be sine arc cosine of negative 3 over 7. Again, we're going to let theta represent what's being plugged in. And we're going to go ahead and see, first of all, we're going to see which quadrant is this in because they don't always tell us. In fact, in the last one, they didn't tell us either. We had to figure it out. So for here, remember that our cosine is between 0 and pi. And so it's either going to be in the first or second quadrant. Okay? And because this cosine is negative, where is cosine negative? In the first quadrant or the second? In the second quadrant, the x values or cosine is negative. Okay, so we have the triangle right here. Okay, so based on that, let's label it. So remember, this is opposite, this is adjacent, this is hypotenuse. So we have SOHCAHTOA, right? So we have cosine is adjacent over hypotenuse. So adjacent is 3, -3 because it makes sense for cosine to be negative, and the hypotenuse is 7. Okay, based on that, can we find the opposite in order to get the sine of this angle? Yes. So let's just do the Pythagorean theorem, which says square the legs. I could just call this B, where B represents opposite. Square the legs, that equals the hypotenuse squared. So this is 9 plus B squared equals 49, and then just do the algebra. Okay, so that means B is the square root of 40. Okay, and we could leave it like that. Your homework might make you simplify it, but we could just leave it like this for the sake of exams, or at least the textbook leaves it like that without simplifying. So now we have what we need. Okay, so now we can finish solving. So this is the same as sine of theta, since we use this specific theta and labeled the triangle according to what was given to us. Okay, so then let's just get the sine and we'll be done. So sine is opposite over hypotenuse. So it is going to be the square root of 40 that we got over 7. And so that's it. We're done. We don't have to rationalize everything. Alright, and that's it. Of course, if you have to simplify it, you can simplify it. So 40, you can split as 10 and 4. 2 and 2, you have a pair, so you could also write this as 2 square root of 10 over 7. So if you need to simplify, review simplifying radicals, you can, but this is the answer, the overall answer. Alright, I'm going to do one last one that has to do with square roots, and as you can see, you get the hang of it. Alright, so last one for this section. Okay, so now we have to think about this. So we don't know what the square root of x squared minus 16 over x is, but they're telling us that it's for some x greater than 4. Alright, it's a new problem. This is number 8 in your textbook, page 621, in case you want to go back and look at the textbook and the homework. Okay, so if you were to plug in a value bigger than 4, such as 5, right, then this would be 5 squared, which is 25, minus 16 is 9, square root of 9 is 3, so this would be 3 over 5, which is positive. So where arc sine be positive? Remember, it's either the first or the fourth quadrant. So that means that it is in the first quadrant. Alright, so let's go ahead and create our right triangle. Okay, so based off of this, we're gonna let theta equal what we're plugging in, and we're gonna label the triangle. Okay, so remember that sine, we have opposite over hypotenuse. Again, remember that if you're trying to solve this out, you can get the sine of both sides. And so that's why we're getting the sine of this in order to label the triangle. Alright, just to tell you, if I were to get the sine of the arc sine of this guy, remember that when we plugged in arc sine, you had to be between -1 and 1. And we just plugged in and we got a fraction, right? Because we're divided by x. So this does satisfy the rules. Okay, on page 620. And either way, let's go ahead and let's label the triangle. So opposite over hypotenuse. So opposites will be the numerator. Hypotenuse will be x. Go ahead and find adjacent using the Pythagorean theorem. So it's going to be leg, I'll let adjacent be 8. So it's going to be 1 leg squared plus the other leg squared equals the hypotenuse squared. And that means that h be the hypotenuse. So we're not getting confused with this x. And now solve. Okay, so, oh, what am I saying? this is supposed to be the same x because it's the denominator. Okay, so now let's square it. So a squared will stay like that. Whenever we square a square root, it cancels and it'll just be x squared minus 16. And then this is x squared, right? And now let's do the math. We're gonna take away x squared, take away x squared, so it's going to cancel. So we get a squared minus 16 equals 0. I can already see the answer is 4, right? But let's solve. So if we were to add 16, right? This is just the work behind it. That means a has to be 4. Adjacent has to be 4 based on what was given to us. Okay, and again, this is just the Pythagorean theorem. I squared one of the legs. A as adjacent, since we don't know it, we're trying to solve for it. Then the opposite squared, which canceled, and then the hypotenuse is x. So it's x squared. Conveniently, the x squareds cancel, and now it's just a square root method, so I got 4. So are we done? Not quite. Almost though. Now we just have to get the tangent of that theta. Okay, so tangent is opposite over adjacent, so the opposite on the triangle over the adjacent, and we are done. Okay, so that's it. Again, there's more. There are word problems, but it goes back to, do you know your trig function in SOHCAHTOA? You can always conveniently set it up. So for example, if they just give me opposite and adjacent, and I'm trying to figure out angle theta, okay, then what do? Then I'm going to set it up that function, right? So if I'm just given opposite and adjacent and I'm trying to find theta, what I can do, maybe I'll make it an easier problem. So let's say that you do the word problem, you do the Pythagorean. Okay, so you have a word problem. I'll just read it for you. So it says a yardstick. Okay, so a yardstick casts a 4 feet shadow when the sun is at an angle of elevation theta. Okay, so a yardstick, which should be this yardstick, cast a 4-foot shadow when the sun is at an angle of elevation theta, right? So right here. And so it says, can you determine that angle of elevation of the sun to the nearest 10th of a degree? Well, because it only gave us the length of the yardstick and the shadow that it cast, you could do Pythagorean theorem, you know, and all that, and get 5 for the hypotenuse. But instead of doing all that work, which I'm sure you call from pre-calc, instead what we can do is, oh, I have opposite, I have adjacent, tangent is opposite over adjacent, so I can get the tangent of the angle. And then if I'm trying to solve for theta, which is exactly what it's asking us for, how would we do that? You would get the arctangent of both sides. Okay, remember I wrote it earlier, but I erased it. When you plug in tangent in first, well, we don't know what this theta is. Let me see. Well, we'll just make sure that our result is between negative pi over 2 and pi over 2, because in order for our tangent and tangent to cancel, this theta has to be between negative pi over 2 and pi over 2. Okay, so these are going to cancel for now. We're going to give benefit of the doubt. We're going to go ahead and get arctangent of 3 over 4. Okay, which is, when you plug into the calculator, you get 36.9. Is that okay? Is that in between the first and the fourth quadrant? Yes, of course, this makes logical sense, right? We don't want an angle to be negative. So this sun is at an elevation of 36.9 degrees. Okay, and that's it. So we got it. And so that's what you can do. Of course, if they gave us adjacent and hypotenuse, then I can get the cosine, set it up, get the arc cosine, and then of course whatever my answer is, I have to make sure that it is within the right restriction. Okay, but like I said, we already know the restrictions of arc sine, arc cosine, and tangent. So when you get your answer, you just double check that it makes sense and that it's allowed to cancel. Okay? Okay, so that's the rest of 5.7. Now I'm gonna finish 6.2. Check out the next video.